look at adding and subtracting rational expressions. So as we learned, rational expressions are simply just fractions. So when we're adding and subtracting, we just want to remember our basic rules of adding and subtracting regular fractions. For instance, adding 1/4 plus 2/7 or 1/4 plus 3/4. And the important thing to remember is that we need a common denominator. Okay, so let's start nice and easy. Let's add and subtract with like denominators. So what we're going to make sure to do is we're going to factor the denominator. Now we're going to find the domain if it asks you to now. If it doesn't, then don't worry about it. Then combine the numerators, but keep denominator the same. And lastly, simplify. So for the first one, we have 5s as our denominators, so there's nothing to factor. If I said find the domain, in this case, our domain is all real numbers, right? There's no excluded values. And so now that we have that same common denominator, we simply just combine the numerators. In this case, can I combine 3y and x? No, but I'll write it in standard form. So x plus 3y is my numerator, and then I keep my denominator of 5. And simply that's all I can do. Okay? For B, very straightforward. Okay, again, we have common denominators, but I'm going to factor them. That denominator is m minus p and m plus p for both of them. So now what do? If I ask to find the domain, you would do so. In this case, I wouldn't ask that since we have our two variables. We're not going to get into that. Now we simply combine our numerators. So my numerator is m plus p, and I keep my denominator, which was m minus p, m plus p. At this point, I can simplify. There's an m plus p up top and on the bottom. So my final answer is 1 over m minus p. Okay, so that's how we add and subtract with common denominators. What happens if they're not common denominators? If they're not common denominators, we need to find a common denominator. And ideally, you want the LCD, the least common denominator. If you choose something larger, you'll have more simplifying to do. So there's two scenarios. We either have monomials as our denominator or polynomials. If we have monomials, we find the least common multiple of the coefficient. Okay, so if we have 7 and 14, 14 would be our common denominator there. If we have variables, then whatever variables show up, you need to include them, and you include actually the highest exponent. If we had something like x to the 5th and x squared, but you only chose x squared, we lost a bunch of x's. So you always choose the highest exponent, even though we're looking for the least common denominator. If it's a polynomial, then you want to make sure to factor each denominator. We include all the factors that show up once we factor. However, if there's a common one amongst the two denominators or three denominators, we only need it once. But if a single denominator has two or more of the same factors, we need to include it that many times. So if x plus 4 shows up twice in one single denominator, use x plus 4 twice. Okay, so let's look at a couple examples. The first example is two monomials. So we look at first at 12 and 32, and we think about what is the least common multiple of those coefficients, right? So we have 32. Does 12 go into 32? No. So the next thing after 32 is 64. Does 12 go into 64? Nope. So what comes after that? So 32 times 3 is 96. Does 12 go into 96? Yes, it does. So 96 is the coefficient part of the least common multiple. And now I look at my variables. They both have a b, so I have to include that. and the highest power is 4, so I have b to the 4th. They also both have c's, so we include that, and the highest power is to the 5th. If one of them had a d, then make sure to include the d as well. If one of them has an e, and then include that one. Okay, so there is our least common multiple or denominator. Okay, let's look at b. This time around, we have 2 polynomials, so we have to factor each. The first one would become x minus 7 and x plus 4. And the second one would become x plus 4 and x plus 4. Really important that you factor correctly, right? If you factor incorrectly, then everything's going to be wrong. So that's why factoring skills are so important. So now we look at these two, and we include the factors that show up. So that LCM is certainly going to have an x minus 7, because we see x minus 7 showing up. It's going to have an x plus 4, because we see that showing up not only in the first one, but in both of them. Now, we're actually going to include that x plus 4 twice, because in the second polynomial, it shows up twice. So there's my LCM. Notice I don't need to have x plus 4 3 times, okay? We include it once for it showing up once in each, and then I include it that second time because it shows up twice in my second polynomial. And for our LCMs, you do not need to then FOIL and multiply. You can leave them in factored form. Okay, so I'm going to have you try a couple of these. We have A, B, C, and D. Okay, but I'll do one of them with you. Okay, so I'm going to do C with you. So if we look at C, the first thing that we need to do is we need to find that LCM. So that means I factor my first denominator. It's going to be x plus 4 and x minus 1. I factor my second denominator, which would be x plus 4 and x plus 3. If I was to find excluded values and domains, now would be the time to do so. So that would be, we exclude negative 4, positive 1, negative 4 again, and negative 3. Okay? It does not ask us to do so, but please understand now would be the time to find that domain before we cancel anything. Okay, now that we are going to put these together, we need our common denominator. So that least common denominator, if we use the rules we just discussed, they each have an x plus 4, so I'll use that. It only showed up once for each, so we'll only use it once. The first one has an x minus 1, and the second one has an x plus 3. So my least common denominator includes these 3 different binomials. Okay, from here, now we need to rewrite our fractions with that common denominator. So our first fraction will have a denominator of, like we said, x plus 4, x minus 1, x plus 3. Our second fraction will also have that same denominator. Now what I need to do is, the fact is because I switched my denominators, right? I altered my denominators, I need to alter my numerators. So the first one has an x plus 4 up top to begin with. And then what changed in the denominator is the x plus 3. So I need to put that up top as well. The second one had an x plus 4 and an x plus 3. So what changed was the x minus 1. So I need to put that up top as well. Now, please note, do not try to cancel at this point. If I try to cancel the x plus 4s and x plus 3s in my first fraction and the x minus 1s in the second fraction, you're going to be left with 2 fractions with different denominators again. And now we're back to square one. So we have to make sure that even though we're adjusting these and it looks like we could cancel, if you cancel, you're just back to square one with uncommon denominators. Okay? So now that we have those common denominators and we've altered the numerators properly, what you can do is you actually simplify those numerators. Okay, so what does that mean? I'm going to use a different color so we don't have to rewrite tons and tons, and I'm okay with that. Is this numerator up top will actually become x squared plus 7x plus 12, right? We'll have x squared, 3x, 4x, 12. The second one will become 2x squared. Then we have minus 2x and minus 3x makes minus 5x, and then plus 3. So I'm simplifying those numerators, and I always just double check those calculations to make sure that I haven't messed up somewhere, because again, if you make one little mistake early on, the rest is going to be off. But I think we are in good shape. So now what we do is now we can actually combine, right? We're at the point where we have common denominators. So now I can simply combine the numerators. Be careful here, we're subtracting, right? So what is that new numerator going to be? I'll have x squared minus 2x squared. That gives me negative x squared. I'll have 7x minus negative 5x. Recall that's really going to be plus, so plus 12x. And then 12 minus 3, which will be 9. So here's my numerator, and I then just copy my common denominator. The last thing I try to do is simplify. So can I factor this numerator? What multiplies to negative 9 and adds to 12? There's nothing. So since I can't factor that, there's nothing I can cancel on top and bottom. So here's my final answer. Okay? So again, when you're adding and subtracting with different denominators, we find our denominator, common denominator, we adjust our numerators, simplify those numerators, and then combine. If you can, always try to simplify. Okay, so you try A, B, and D. My hint on D, that I'm going to write right here, is to factor out a negative 1 in first fraction. Okay, so give those ones a try, and we'll see how you do. Lastly, we have complex fractions, and we're going to look at complex fractions a few times. We already saw them before where we had a single fraction over a single fraction. This time around, they're going to get even more complex, okay? What happens here is we may not have just a single fraction over a single fraction, right? Look down at letter C. We have a bunch of fractions. So what we need to do is we need to condense the numerator and denominator so that we do have that single fraction over a single fraction. It will allow us to simplify. So I'm going to do B for you. A should be review. And then after I do B, you try C. So for B, what we need to first focus on is this guy. That is not a single fraction. So I need to use my adding and subtracting rules. Those are not common denominators, so I need to make it a common denominator. That means the common denominator will be xy, right? They each have one has an x, one has a y, so our common denominator is xy. Now we have to adjust our numerators. So the first numerator has a 1, and we change the denominator from an x to a xy, so that numerator has to now get a y. The second one just had a y. I included an x, so we need an x up top. Okay, now I'll just recopy the second fraction. That second fraction looks good because it's already a single fraction. At this point, I can now combine that big numerator and make it a single fraction. So that will simply be y minus x all over xy, and then all over the other fraction of x squared minus y squared over xy. At this point, we have a single fraction over a single fraction. So what can I do? I can multiply by the reciprocal. So I'm just going to take it nice and slow. You can kind of do some of these steps in your head, but I have that first numerator, and I'm dividing by my second fraction, which means I'll multiply by the reciprocal of that. So now that we are multiplying, remember when we multiply, we need to factor. Well, I see a lot of things in common. I see a lot of x and y's. The first one has a y first, though. So that's going to indicate to me I should factor out a -1. If I factor out a -1, I now get a positive x and a negative y. For the second fraction, that denominator is a difference of two squares. That will be x minus y and x plus y. Now that I have factored, I can actually connect the bars and cancel. We have x minus y on top and bottom. We have the xy's on top and bottom. So I'm simply left with -1 over x plus y. And there's my answer. Okay, you try A and C.